Hey everyone, happy Monday. Mr. Eder here. I'm just trying to help you out with this VSEPR Theory virtual lab and maybe clear up any questions you might have. Of course, you can always email your instructor if you encounter some issues. But try to work through this. We know this is your first exposure to this VSEPR theory idea, VSEPR valence shell electron pair repulsion theory. And we just want you to be exposed to what's going on in three-dimensional space, so that way when you get to the lesson tomorrow, some of the words and vocabulary will make a little more sense, and you'll also have an opportunity to ask questions today or tomorrow during office hours to whoever your instructor may be. So when you get to this slide, go to the link here, and it will open up this page. Click on play. And you want to first go to the model. So part one deals with the model. And let's start by getting rid of anything that's on the screen. And then let's read the directions. The central atom is the purple atom. And let's remove the domains using that remove button, the X that I hit over here. We want to add the domains required as in that first column. I know it says column 2, but in the first column. And then click on molecular geometry. So that's down here if I click on molecule geometry. And I want to click on show bond angles. And then you will be recording this information. So the ball and stick drawing is what you end up seeing here. And try to make it match as best as you can in 3 dimensions. It doesn't need to be too difficult or too impressive of a drawing, but try to make your drawing match what you see on the screen. So A, I'll run through the first 2 with you. A, 2 atoms double bonded. So I'm going to add 2 atoms that are double bonded. And you see here that it is 180 degrees is the bond angle. And you can also click and move this around. But you should draw write the geometry name as linear. The bond angle is 180 degrees. And then the ball and stick drawing, right? These are the balls, the sticks are the bonds. You should draw the ball and stick drawing in the box on the right side. So that would be A. When you go to B, remove everything. And for B, 2 single bonded atoms, 1, 2, and 1 double bonded atom. So I add that in here. And now we see a bond angle of 120 degrees all the way around. The geometry name, molecule geometry, is trigonal planar. Bond angle is 120 degrees. And then draw this ball and stick diagram in the box. So do the same for C, D, E, and F. And there's a little comparison on the bottom of this page for 1 and 2. It also then asks you on 3 and 4 to make predictions. If you flip over the page, we get to real molecules. So I'm going to jump ahead here and maybe come back and watch this if you need to, but I'm going to jump ahead to real molecules. That's this tab on the bottom. When I click real molecules here, it then wants you to select water as the first one. And what's the geometry name? It's bent. How many domains does it have around it? A domain is a lone pair or a bonded pair. So water has 4 domains around the central atom. And then we want to show the bond angle. And the bond angle here is 104.5 degrees. So this is the real molecule. The bond angle of the model. So if I click on model, it's 109.5 degrees. Okay, so you would write that in and then do the ball and stick drawing for water. Do the same over here for carbon dioxide. Compare the model and the real, okay, with bond angles and shapes. Do the same for ammonia and methane. I hope this is helpful to get you off to the right start. Again, this is just trying to get you to be exposed to the idea of molecules have shapes. What are the names of those shapes? And why do you think that the angles are maybe a little bit different? Okay, so again, email your instructor or join office hours if you have any questions.